Well, hello and welcome to the Smells Like Money podcast. Join me, Suzan Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. This week's episode of the DooDoo Diva Smells Like Money podcast is sponsored by Welcome to the Future of Industrial Automation with Riot SCADA. Take command of your operations like never before. From oil and gas to energy grids, Riot SCADA adapts to your industry, providing a seamless and powerful solution. Monitor, analyze, and control your processes with ease. Their intuitive interface puts the power of information at your fingertips. With scalability to grow with your business, customization to meet your unique needs, and remote access for control anytime, anywhere, they empower your control and drive your success. The future of industrial automation is here. Transform the way you operate with Riot SCADA. Well, hello, everybody, and welcome to this week's episode of the DooDoo Diva Smells Like Money podcast. Today, we are visiting with Josh Ford, who is the Director of Engineering for a company called BNtelligence with a really cool new technology called PipeAId. And we're going to have a demo of that a little bit later. And what makes this so exciting, as many of you know who have known me in the industry, I cut my teeth in CCTV inspection and data collection software. So whenever I find something new and exciting coming onto the forefront or coming onto the stage in this industry, I'm really excited to bring it to the forefront and introduce it here on the show. And so with that, welcome to the show, Josh.
Oh, thank you very much. I'm glad to be here.
So Josh, to kind of lay the groundwork for this, tell us a little bit about how PipeAId, BNtelligence, even you and your experience in the industry, how this all came about, because I think this is kind of a fascinating story.
Sure. So PipeAId was actually developed inside of an engineering firm, Burgess Niple, that's about a 112-year-old firm. We're based out of the Midwest. And I'll start from, there's two stories for how we started PipeAId. And the first one is mine. I, just like you, Susan, I cut my teeth with sewer inspection. So I spent a lot of time, I've been at Burgess Niple, now BNtelligence, for 17 years. And I first started out, as every new engineer does, out in the field. So I got PACP trained, and I spent a lot of time in the backseat of the sewer inspection vans watching the video. So going through, providing all that oversight to make sure all the header data was correct for the upstream manholes, downstream manholes, dates and times. And then as I was sitting there watching, as the camera kind of runs from one end of the pipe to the other, but making sure that all the coding was correct. So that really critical QA/QC step on the backside, we didn't need to do that as I was in the office. So I could make sure that it was getting coded correctly in the field. And then it was very minimal back in the office to make sure that it was correct. And as I was going through and watching it, what I found was, one, it's that subjectivity piece. What I thought was a crack, somebody else thought was a fracture. And that might not sound like, big deal on a pipe segment, but if you're looking at 1 million feet of pipe, all of a sudden that subjectivity and bias, that becomes very important. So it was accuracy. And I realized that, one, the contractor didn't like me very much when I was constantly correcting them for what I wanted to see. So that added time. And obviously there was a lot of time spent in the field. A pipe inspection, if you're going 30 feet per minute on a 300-foot stretch of pipe, should take 10 minutes. And it took a lot longer. And even I'd be sitting there at 10 o'clock at night, and we got maintenance of traffic going, and I couldn't wait to get done, to get moving. There was just something at every joint. And then there was the piece in the office. We spent a lot of painstaking hours on the times where I wasn't out in the field, going through reviewing the video. And then it was an issue of, do I have the correct software to add the code to the video? Or did we have to have some secondary application going through and where we're tracking and monitoring so that we could record those? So that was an issue for us as well. And then when cities go through and they bid out their cleaning and inspection work, it's always the lowest and best. And what I found was good luck convincing anyone that they weren't the lowest and best, really the best. So they were going to the second lowest. So there were some issues there. So there was always a problem with making sure you get accurate coding, at least from my standpoint. And then the pricing was there. In the early 2000s, I talked to contractors that were making money hand over fist at $1 a foot, not coding. And then NASCO PACP came in and they had to start to doing the coding, and that raised the cost quite a bit. So I realized early on there was some issues with speed, with time, with cost, with accuracy. Because really what clients are doing with this data is they're making the data-driven decision of what am I going to repair, maintain, replace. And then on the second side, as an engineering firm, we realized that AI was quickly coming into our market and kind of trying to think, how are we going to go through to adapt to this type of technology? And we started to run some proof of concept testing on with computer vision AI to see what could it do. And we had 3 quick case studies that we were considering. One of them was wetlands, one of them was bridge inspection, and the other one was pipes. After talking to some industry experts, we realized that really the backbone for computer vision AI, it's a bunch of pictures. And since I've been doing sewer inspection for 17 years and others at Burgess and Niple had been doing it for substantially longer, we had the data set sitting around. So we didn't have to go through to start collecting it. And we went through, partnered with another tech company to go through to help us set it up. And our first test really was, can an AI tell the difference between a cracked pipe and a fractured pipe? And as soon as we found out that it could, well, then we started rolling out full scale to kind of figure out, okay, let's really test the waters here to see what can it do and what can it do, so that we can go through and create an AI that does as advertised. And I think there's a lot of unknowns surrounding what AI does do and what doesn't. So that was really critical to us to make something that was accurate, that performed as advertised, and really met the need in the market. So really about 5 years ago, that's when PipeAId started, and we continued to develop, improve, sell, and market. The models go through to get smarter as the more pipe that we process. So that really lands us where we're at today. Right.
So now, as it sits, there are some other firms that others are probably aware of that do the AI coding, and they're done on different models. So how do you provide this tool to your end customer, and how does it, where does it sit, its position in the toolbox for the contractor that's doing the pipe inspection, or a municipality that's doing, there's a lot of municipalities that have their own CCTV trucks that are doing this, sitting, how does it interface with, asset management software, work order software, GIS, and all those things? Where is its position in the toolbox?
Sure. So kind of quickly, closed circuit television is most commonly what utility owners use to capture the condition assessment.
Right.
And that's been around since the 50s and 60s. So if you kind of think about when you're set in your ways, do you want to go through to change? Well, there's utilities out there, contractors that have been doing the same thing for the same way since the 50s and 60s. So, and then also there's a cost piece. The sewer, I would say sewer inspection market, it's kind of it's a very small circle, but it is a competitive space, and clients and contractors, municipal utility owners, they already like the software that they're using. They're familiar with it. They know how to start the inspection. So we didn't want to go through and in that sense, kind of really create something that they had to go through to scrap everything that they had. You couldn't use the
So
same.
it's not displacing your standard CCTV data collection pipe inspection software.
Correct.
Ah, okay. So this is like a bolt-on to something that they're already using, whether it be, PipeLogix or WinCan or Granite or any of those. This works in tandem.
Correct.
Correct. Okay. All right.
So it is a post-inspection tool. So utility owners can go through to capture the data the same way that they always have captured, with the same software, the same workflow. Really what it means is they don't need to code in the field out anymore. And it makes that data capture much more efficient. So it's way more streamlined if the camera can be following, 6, 8, 10 feet behind that cleaning jet head. And there's constant communication when the guys are on the walkie-talkie. Person in the camera truck can get them on the phone and say, the pipe's clean, keep going, or it's not. You got a lot of debris, you got roots, or you got a sag to pull the water level down. The person in the camera truck isn't stopping to code at every single joint. In terms of, so we don't have the traditional software that sits on top. We get the CCTV inspection videos. We go through to process them, and we code with what our AI picks up, and then we supplement with our NASCO PACP trained engineers to add everything that the AI does not identify. And then we do our reporting inside of GIS. So all the all that I'm familiar with, asset management softwares, they're all GIS based. So in terms of naming convention, it's something that is designed for clients to be able to integrate into their existing GIS. So our naming convention matches that. And for the softwares that we've worked with, it's really seamless integration of our data set into what they're already using. So in terms, PipeAId is a pay by the foot. So they're paying to capture and process the data by the foot, but there's no other additional capital outlay to go through to use the data. One of the benefits of not having our own software and really relying on GIS is that there's not going to be any kind of additional costs for other modules to go through to kind of pull in, if clients, I don't know what all the modules are available with the different softwares, but really it's a cost savings for them from that standpoint.
So they can get more feet done per day.
That's correct.
That's the whole key. So if I'm understanding it right, then they send that footage off to you, and then you're processing it as a service and then sending back the reports to them. So now, do those reports also interface with some of their analysis reports in the CCTV data collection software? Because some of these, data collection softwares have some pretty powerful analysis reports that the operators in the cities are used to working with. So how does that work?
So I guess two pieces. A lot of the reports that I've seen, and I'll take the asset management aspect out of it, but a lot of the reports that the CCTV softwares have, for the most part, what they give you is, some PDF documentation of what was inspected. There's images of where the breaks or the taps or the roots happen to be, but they're really static PDFs. Our reporting really kind of replaces those. So it shows you in space inside of our digital twin exactly where every break, hole, tap is. So you're not having to go through, look at a piece of paper and kind of start to figure out where that is out in the field. And I think the benefit of that is inside of an organization, you definitely have folks with the institutional knowledge that know exactly where that pipe segment is at. They know the residents that are on it. They know the last time it was there. They know the problems. They know the cross bores. But as you start to move away from those folks, either they retire, they're not available, you've got some turnover. It's the GIS that makes that much more valuable. And inside of that, we've got some imagery attached to it. But if the clients wanted to go through to import our data into their existing sewer inspection softwares to go through to get those types of reports, that's something that they can go through to do. And certainly, since this isn't a canned service, we try to specialize as much as we can. We can go through to adjust the output so that it's easily imported into their software of choice.
So you make sure things play nice. So this brings me to the thing that I really wanted to showcase on this particular episode. Spoiler alert, we're going to do a deeper dive on a second episode on this to actually show how it worked in a real world case, so you can really understand it. But what I am going to ask Josh to do now, for those of you who are just listening in, you might want to come back in if you're interested in seeing the visual, but he's going to narrate what's going on the screen. But he mentioned the term digital twin. And so for those of us who may not be completely familiar, like I've heard this, and I'll be the first to say, I know just enough to be dangerous, but I've heard it. I think I know what the concept is, but I'd really like to fully understand what digital twinning means as it relates to this particular aspect of technology. So with that, Josh, you've got control of the screen and you can bring up a demo of what PipeAId is.
Yep.
And what that means.
Can you see my screen?
Yes, we can now.
Okay, perfect. So really what the digital twin is, it's designed to be something that overlays really seamlessly on top of an existing utility owner's GIS. And we can go through to do the reporting in a couple different ways, but one of the first things that you can do is you can start to visualize the condition of pipes. And for this example, I've really tried to make it easy. We've got red, yellow, and green. Green is good, red is bad. And this is all something that's completely customized. With utility owners, they spend a lot of money setting up their GIS. They have the staff that know how to do it. My opinion is there's no one better to go through to manage this data to help with decision-making and day-to-day operations than the utility owner. And GIS is something that's been rolled out wholesale. So whether you're looking at just understanding the colors, what's good or what's bad, or you want to do that deeper dive into, okay, well, what's bad about it? You can do all that inside of GIS. And the way that we set this up is you can go through on the left side of the screen, but you can start to visualize from a structural standpoint, we'll start off with, but everything that was recorded. So if you want to look at just the cracks, and these are still labeled the same, green through red, if you want to look at the fractures, or you can turn these off. And a lot of times when you're making the decisions for what you need to fix, it's that near-term look for what you need to fix. So you're really looking at the worst of the worst. So what's broken, where the hole's at, severe deformations and offset joints. And with PipeAId, you can then start to dive down to look at these pipe segments. And each one of these dots, kind of color-coded, red for not quite so bad and really dark red for really bad. But this is the spatial location of every defect. So if you take it back to those PDF reports that you're used to looking at, you can see I've got a break, 50 feet up from a manhole. That's exactly what this is showing you. It goes through one to start painting that picture of where's it at out in space, under a street or not. If it's in a rear yard, how are you going to access it? If you're in a street, how are you going to maintain that traffic control? But you can start to click on these points. And what pops up in the left-hand screen is some imagery about what we're looking at. So first thing that we get is this longitudinal view. We can look right down the barrel of the pipe, and it tells you, is the pipe, from a novality standpoint, is it good or bad? Has it started to deform at all? It also gives you the extents of how far the defect that you're looking at is around the circumference of the pipe. And this is something that I've seen a lot of sewer softwares, at least in my experience. You don't really get this view. You typically get a view like this, kind of right up against the pipe.
Right.
And so it's hard to understand exactly how bad that is. So inside of the digital twin, we can attach 1 to 10 images to a defect to really give that full view for what the condition of the pipe is. We can then move on to more O&M type defects, and you can do the same zoom out to see, where's the pipe good, where's the pipe bad. If you're looking at things like roots, deposits, I&I, you can start clicking all these points on and see exactly where they are over the pipe. For things like roots, one of the benefits is as contractors or municipal owners crews go out to clean the pipe, they can kind of know where they need to focus that root cutter on. They got that little dial on the wheel on the combo truck as it's running up, so they can kind of keep focusing within maybe a 5-foot span of where some defects are or roots are. If they get a really large root mass, a lot of times it'll go up so far and they get some resistance. Well, they can look at this map. Being GIS, it's available through ArcGIS online type environment, but you can see exactly where these are and you know where to go.
Wow.
you can go through then, and in the same way, you can start clicking on some of these points, and you get the same imagery that is attached to it. So you can see where the roots are. Are the roots very bad? To really paint that picture from an O&M standpoint, how are you going to do your work? What you can also do is we show you what types of laterals you're dealing with and where those laterals are, whether you're looking at break-in taps, factory, if they're capped or defective. We show you what side of the pipe that they're on. So really it tells you what home that they are providing service to. In the same way, you can go through to click on these images. So you've got a longitudinal shot to see where that's at in the pipe. And then you can have the perpendicular shot as the camera operator pans to look up to tell you if the tap is capped or open. And from a use standpoint, aside from understanding what's capped and what isn't, what's active, if a municipality happened to get a call from a resident saying, hey, I've got a backup in my lateral, you could go through easily, take your phone, you've got the digital twin, you can stand right on top of this tap right here. Actually, we'll do this one since it makes my point a little better. But you can stand right on top of this tap and you can start turning on everything that was found in the pipe. Say, we don't see anything in here that's going to cause a backup. And then we can go through, you can look right up this tap here. You can tell the homeowner, I don't see anything here close to the main line that's going to cause an issue. But what I do see is tap, tree, house. You probably have some roots in your lateral. We recommend that you call a plumber.
Got it.
And then finally, it's the abandoned inspections. So a lot of times when a camera can't make it all the way from one end of the pipe to another, there's a more serious issue. Either there's a big root ball or some debris that needs to be cleaned out. So you're talking about work order generation, or I've seen instances where a phone pole has been driven right through a sewer. You can see exactly where those points are. You can see how much of the pipe was inspected versus wasn't inspected. So if you happen to move one step further into design and then construction, and a lot of times it's kind of hard to know that there's a piece of pipe right in the middle that wasn't inspected. And then what you're looking at is change orders and delays because that wasn't identified early on. And with the digital twin, it goes through not just to help you make decisions on what to fix. It's when you go through to actually do that fix, it helps you whether you're doing construction and an open cut repair. If you're doing rehabilitation, you can start identifying where the sags are because there's no quicker way to get a lift in a liner than inverting quickly through a sag. You know where your I and I is. So it's got some benefits from a lot of different angles.
Wow. This is absolutely fascinating, Josh. And so it's, we've come so far with our data collection and GIS and work order. This is just like one more layer as I see it to make us more efficient and to help cities, asset owners make even better educated decisions. It's removing another layer of guesswork, especially I would think for prioritization.
Yep, that's exactly right. And really, it's kind of interesting you say guesswork, and that's really where the AI and the GIS fits in. It's because what's the cost of fixing the wrong piece of pipe? Going through and having all this data right in front of you, you can start making the, let's say, argument, but validating your reasoning for what you're fixing. So you can go through to talk to your constituents, exactly, other stakeholders. And show them right now, this is the bad pipe, this is why it's bad, and this is why it was chosen to be fixed.
All right. So for those of you who are listening, if you want to know more information about PipeAId and the company behind it, BNtelligence, and maybe to get a more demo, a deeper dive demo, how can they do that, Josh?
I can be, my email address is really the best way to reach me. And that is joshua.ford@BNtelligence.com. So it's intelligence, but without the I.
I love it. Which of course stands for the Burgess and.
Yep, Burgess and Niple.
And Niple. Here, I was getting ready to mispronounce it. So Burgess and Niple, little play on words. I really, really like that. And so you can also find information at PipeAId.com, and that's PipeAID.com. They've got some interesting case studies. And so for those of you who have been intrigued by this episode, stay tuned because we're going to continue our visit on the next episode with Josh to review an interesting case study of where PipeAId was applied for a city in helping them develop their capital improvement program, their rehab program, and basically where to spend their money wisely. And so stay tuned. And thank you again for tuning in, everybody. Thank you, Josh, for being on the show. And until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.